Hello, we are going to be using logarithm rules. So here is a picture of the log rules. There are four that we're going to be looking at for this section. Actually, we're not covering the change of base. I put it on here for completeness. It's pretty easy. You just plug in the numbers and you use that whenever you need to put something in a base that you might not have on your calculator. So if you have a base 7 problem and you need to get a number for an answer, you can use this formula to change that base 7 to a base E or 10 and then use your calculator on it. So that's what that one is for. The other three are what we're going to be using in this video. And these relate to the exponent laws. So if you remember the exponent law, where if you have x to the n power plus x to the m power, that equals x to the n plus m power, that is the equivalent of the first log rule, where on one side you're multiplying, on the other side you're adding. And since logarithms or exponents are inverse functions, they have these related rules to each other. The second one is the same, only you're doing a division on one side and a subtraction on the other. And then the third one is the most important one, where you can bring the exponent from your argument out in front of the log. So let's start with, we have a bunch of examples here. We have log 2 plus log 5. So the first of the logarithm rules is that when you have this situation where you have the same base logs that are added together, you multiply the arguments of the logs, arguments meaning the thing that the log is working on. So that becomes log of 2 times 5, which is log of 10. Since it's base 10, you're asking the question, 10 to the what power equals 10, and that is 1. So the answer is 1 for that one. In the second problem, we're going to use the same rule. We've still got the same base on both logs. They're added together. That means we multiply the arguments. So we end up with log of x squared minus 2x. On the third one, it looks the same, except now we're subtracting instead of adding. That means we're going to divide instead of multiply. On the fourth problem, log of x cubed, we're going to use the other property, which brings the exponent down in front of the log. This is the most crucial out of the log rules, so be aware of this one, especially if there was only one you were going to learn, this would be the one to pick. And then we have some odd problems where we're expanding and collapsing logs. As you can see, these rules make things either bigger or smaller from the first few examples, and we're going to be going both directions. So first we're going to start with a condensed problem, and we're going to expand it as big as we can. We want to start with the outermost thing that's going on. In this case, it's the fifth power. So we are going to use that power rule to bring that exponent out in front of the log, leaving everything else the same for now. So that 5 comes down in front of the log. And then we're going to look for the next thing that applies to most things. And that's going to be the division. And so that division is going to turn into the subtraction. The reason that we pick that instead of like working with the x cubed is because if we put the 3 out in front, it would apply to the y as well, and it shouldn't. So we need to find something that applies to everything. In this case, that division would work. You could also, if you're being careful, work on the multiplication between the x and the y instead of the division. That's a choice. But just make sure that whatever you're doing is applying to everything. All right, so after we're done with that one, now we're going to separate the x cubed, y, and the division. Those are all the same level in PEMDAS, so we can go ahead and work on that. And now finally at the end, we're going to take those exponents that we've still got in there and move them out in front. All right, let's go the other direction. So contraction, we're going to start with something that's expanded. And this time we're going to start with the innermost thing. To expand, you want to start with the outermost thing. To contract, you want to start with the innermost thing. In that case, it's going to be the exponents. So we're moving those exponents over inside the logs. And notice that I'm very careful to put that cubed on the 2 and the x, so you need to watch your parentheses on these. And so we worked on that part. The 8x cubed comes from 2 cubed times x cubed. And we just keep using those rules backwards until we get to the very most contracted form we can get it in. And that's it. Thank you.